Hello everybody, my name is Jemmy, and today I will be giving you a brief overview on Seaborn. Today is unfortunately our final lesson on Seaborn, but I have a surprise for you. Instead of any old normal lesson, I made it so that it's Pythomon Go. You might know Pythomon Go, you might not, but basically it's Pokemon themed coding, and today we're going to be doing just that. So let me explain how it's going to work. Instead of using the normal Seaborn library that they provide for us, such as the penguins or the flights, we're going to be using our own, which is the Pokemon API I did a video on earlier. So it's basically Pokemon dataset, and we're going to be going to this link. This basically stores every single information we need for this video. So this one right here, and it has all the information we could ever need for Pokemons. So we're going to be using this one, and yeah. By the way, the link for this page is in the description, so you can follow along with me by yourself. Okay, let's go back. Okay, perfect. So now once we're back here, what we want to do first is we want to import all our libraries we're going to be using. So we're going to be importing pandas as PD, importing Seaborns as Seaborn as SNS, and importing matplotlib.pyplot as PLT. Also, after that, we have to put matplotlib inline and the % sign in front in order to show our graph. And let's run this. Okay, now we're gonna go to the important part, which is to get our data. So with the code !wget and then the link, we should be able to store the information. There is nothing at the end, it is just the link. And after that, we will store this pokemon.csv or /content/pokemon.csv into path_Pokemon. So right now it's inside of this, and we're gonna use pandas.readCSV function in order to get the information. Once we did that, we're gonna store it inside of a pandas data frame called dfpoke. So once the information is stored, we can do anything with it. The limits are very low. So now we can just, as I said earlier, we can do anything that pandas allow us. Of course, not like everything, but yeah. First thing, let's print out and print the data frame out, and let's see what it looks like. So we're going to be using the command .head, which basically shows the first 5 rows of our data set or data frame. And here we are. So the first 5 rows look kind of like this. There's the Pokemon name, there is the number of the Pokemon, there is the name, the type 1, type 2, the total, which is all these stats combined. There's the HP, attack, defense, speed attack, speed defense, the speed, the generation, and if it's legendary or not. So yeah, that's the information we're going to be using today. So let's go. Right now, after that, we're going to be setting our style to white grid, which is the original one. This is so that it makes sure, or it guarantees that we have the correct grid that we're going to be using. Okay, and let's create a joint plot first. So I'm going to use the x-axis as the attack and the y as the defense. The data will be df Pokemon, and the hue, I was planning to do something, but I gave up on the idea because it was a little too hard. But yeah, let's do it. Okay, now it should look something like this. It looks very neat, I could say. There's histograms on the outside, and inside is a scatter plot. The way to look at this is you look at a dot, right? And then you look at the attack. So this is around 80 or 85. And then you look at the defense, and it is around not that good. It's around 20, so 85 attack and 20 defense. You can look at this for all the dots, but we can see a very dense atmosphere in here. So this is where the average Pokemon is, between 50 to 70, or 50 to 100, and 50 to 100 defense. So yeah, it's around 50 to 100, 50 to 100. And we can look at like the ones that are the best. And let's look at the best attack. It's this one with more than 175, around 190 attack and 100 defense. So it's a pretty good Pokemon. But let's look at the Pokemon that's good like all around, meaning the attack and defense. So it looks like it's this one right here, this dot. It has the best attack overall, which is 135, and the defense is more than 200, around 240. And there is 2 more Pokemons that have the same defense but weaker attacks. So yeah, this is the best Pokemon overall. Now let's create a hist plot. Some of you might know hist plot as a dist plot, but the dist plot Seaborn has updated, and now instead of calling it a dist plot, they call it a hist plot. I mean, it's not a big difference, but I just wanted to point that out. So yeah, and we're going to be using the speed for this one. This is kind of like a count plot, if you know what a count plot is. The y-axis will be the count, and then the x-axis will be whatever you set in here. Bins equals to 30, KDE, which is the line, equals to false, and color equals to red. Oh wait, shoot, this is not like the count plot, I forgot. It's like a histogram, so, and there's also a count next to it. There we go. So here's like the count, and here's the histogram. So we can see the speed. The count is how much Pokemons there are. So the max is 80 right now. The speed, well, basically the Pokemons that have the most speed around is around 40, I'm pretty sure, or is that too much? I'll give it a 30. No, I'll give it a 40. I'll give it a 40. So basically, most Pokemons have a 40 as their speed, and some of them are really, really fast, like 175 speed, but that's only one of them. So yeah. Let's move on to creating a box plot. A box plot is kind of like a histogram, like a hist plot, but it's going both ways. I'll show you what I mean. So it has both sides. It's like flipped around kind of, and yeah. So we're gonna be setting the X to the generation. There's 6 generations in Pokemon, and the Y to the total, which is the overall stats, and data equals to DF Poke, which is our Pokemon data set, and the palette equals to rainbow. The palette basically just sets the theme of our box plot. Rainbow makes it more colorful, so that's what we're gonna be doing for today. Also, this is to show which generation is the strongest, because it combines all of their stats. As you can see, Generation 4 is the strongest. The reason I didn't choose Generation 3 is because it has a greater variety. So it's from 300 to 500, which actually varies. But the 4th generation, it just has a pretty good minimum, which is 350 to 500 around. So yeah, the best generation is Generation 4, and in my opinion. So yeah. And let's create a strip plot. A strip plot is kind of like a swarm plot, except with less markers, makes it more easy to look at. So we're gonna be using X equals to type 1, Y equals to total. So we're gonna look at what type is strongest, and data equals to DF Poke, and palette equals to set 2. Also, this code is an additional figure so that we can have a bigger grid or plot for us to look at. And here's what it looks like. So there's all the types here and their strongest. So it looks like I think these two are in a tie. So the psychic and the dragon type are the strongest, as over here. So the total is 800, and there's the psychic and dragon type. Okay. And if we didn't have this code right here, then all of it would be squished together, like so. And this is basically what it would look like. It's very disgusting, but yeah. Now it looks much better. Okay, now let's create a count plot. So a count plot is kind of like our hist plot up here, but it's with a scatter plot, I'm pretty sure. So let's get into it. So we only need to set the X, of course, because the Y is a count. So our X will be type 1, counting how much Pokemons have a type. So yeah, and we're gonna set our size to be quite big, kind of like here, and let's do it. I'm pretty sure it's gonna come out like a histogram style. There we go, it's a histogram as I predicted. And in here, the water type is the most common for the type 1 of Pokemon. The flying is the least common because most Pokemon, they don't have flying as their main. Instead, they have it mostly in type 2 because most Pokemon have the ability I can't say ability to fly, but their generic point is not about flying. Flying is like a side superpower. They have like electric or like water type, psychic type, ghost type, stuff like that. So flying is not their main, but in type 2, most of them have their flying in type 2. Yeah, as I predicted, flying like demolishes everything except for ground and poison type. It certainly is the most outstanding. So yeah, that is the flying type. And let's move on. I wonder, wait, I just had a question. The Charizard, right? It's a fire type, it's a dragon type, and it's a flying type. So what is Charizard's main type? I gotta ask it, I'm sorry. Charizard's types. It's fire and flying, is it not a dragon? It's not a dragon type? Oh, okay, it's only fire and flying. Okay then. So, interesting fact, Charizard doesn't have a dragon type. It only has flying and fire. Anyways, let's continue. So now let's create a heat map. A heat map is like a thermal sensor. The more greater the quantity it is, the more white it gets, and the more red it gets, or the more darker it gets. But in this case, we're aren't going to be doing that. Instead, we're going to set the C map to cool and warm. The C map basically sets the theme of our heat map. Instead of being white and black, it's going to be red and blue. Okay, and let's run this. This will basically create like a heat map of our Pokemon dataset. And this is the line down the middle. It's called the diagonal line. And the reason it's all red, meaning everything is correlated to each other, is because they're the same category. So they are 100% related to each other. And let's see some of them that are related, but not the same category. The SP attack for one. The SP attack with the total are 0.75, which is 3 out of 4 fractions correlated. So this means that they are very similar to each other. I think is because the SP attack makes most of the total. Let's see, the HP and defense. HP, defense. Okay, HP and defense are kind of 0.25. And this is good because if it's too correlated, then that means the more HP, the more buff your Pokemon is. And let's move on to our last one, which is the Facet Grid, or the Facet Grid. The Facet Grid looks like this. Okay, let's wait for a bit. Here. So the Facet Grid basically creates multiple grids that we can compare to each other. I made it so that it compares all the generations with using our Pokemon dataset, of course. And the x-axis will be the total. I mean, not the x. Yeah, the x-axis will be the total, and the y will be the count. I'm pretty sure. But yeah, that is our Facet Grid. The Generation 5 has the most total, or like, yeah, the most total, meaning it's kind of the most strongest one. Yeah. So that is our last lesson on Seaborn, at least for a while. I hope you enjoyed today's video, and I'll see you in the next one. Bye!